Okay, we're going to be introing the 5 types of chemical reactions, and we're going to be using that to help us predict chemical reaction products, and then we can go through there and actually balance them. So with those, a couple things you need to remember are when we actually produce products, we're going to start off by, I have to give you the reactants. And I'm either going to give you the formulas of the reactants or I'm going to give you their names. And I'm going to tell you something like, okay, they are going to yield. We already talked about yield means to produce, right? But I'm not always going to use the term yield. I may say something like to produce, okay, to make. I may say something like if it's going to break down, decomposes to, okay, it creates, it turns into, it burns, okay, it combusts, it becomes, it changes into. All those kind of mean the same thing. Something's happened to create something new, right? That's what you're looking for. And that just tells you something is happening and we're going to create something new. That indicates a chemical reaction is taking place. And that's what you want to be aware of. Okay. So it's just words to say, hey, something's happening. And you'll have something indicating what you're starting with. Okay, that's the key piece. The 5 chemical reactions, and once again, these are actually in your notebook already. And I've got them just right here. And this is actually the slides you'll see in your notebook. Single displacement. And what I did for each one, it's also known as single replacement. You'll see it both ways. You're going to start with an element. Remember, an element is going to be a single capital. And then you're going to have a compound. Remember, a compound's 2 or more capitals. Okay. You're going to react them together, and you're going to form this new element. So you're going to have a single element coming out by itself, and you're going to have a new compound, a new combination of 2 or more capitals. So if you're looking for a mathematical formula, you're going to have A plus BC. So an element plus 2 or more capitals. So we've got a compound. Yield, so producing AC. So now I've got a new combination, new compound created, plus B. So we have a new element by itself, a new capital by itself. So I've created a new thing plus another new thing. Remember, law of conservation of mass. All I can do is rearrange the format. I can't get rid of them. So if we put them together, Na plus LiCl creates NaCl plus Li. I color-coded. So A is Na, B is Li, C is Cl. And I showed you that I swapped over. Notice I swapped the Na and the Li. Why would I swap the Na and the Li? Why did I swap basically the B and the A? What's the point behind that? Why didn't I just swap the A and the C? Couldn't I just swap anything? Would it matter?
The A and B have positive charges and the C has a negative charge.
Exactly. A and B are metals. They both have positive charges, and I've got to swap things with positive charges because Cl is going to have a negative. So I've got to make it so I always have a positive negative taking place there if they're ionic compounds. So good. And we see the same thing on this one, but in this case, I've got F, which is going to be a negative. So it's got to replace the negative of Cl. Why is it F2 and Cl2? Why is it F2 and Cl2? Why not just F? Why did I write it as F2? Why did I write it as CF2? Is it from this Cl2? Is it from that? Is it from this F2? Is it from that? Did I do that just to make sure everything balanced? If you look on your periodic table, the answer is already there. What's it show on your periodic table? You're going to need that out. That's what the home audience. If you don't have your periodic table out, this would be a good time to bring it out too. And if I knew how to pause this, I can hide this. But if I knew how to pause the video, I would. I'm not that well versed on this, so I don't know. I don't know what this button does. Do not autofill. I don't care. So, did everybody find F? What do you notice about F? It's got a -1 charge. Did everybody find Cl? What did you notice about Cl? It's got a -1 charge. Did you find out anything else about them? They're diatomic, exactly. Those are elements that are so reactive they cannot exist as a single atom. So they have to be written as F2 and they have to be written as Cl2. Regardless of what they're bonding with later, they have to be the F2. They have to be the Cl2. It just so happens in these compounds, they have to have two of them to balance out the charge. Okay, but getting back to it, A, okay, C, there's B, C, there's our Cl2. And we just rearrange to swap out like charges. In the case below, positive and negatives. I'm still going ionics, right? I've got multiple capitals here because I've got a positive and I've got a negative, VOH. So yeah, I've got 3 more capitals, but this C is representing something with a charge, that polyatomic ion. I haven't changed anything. So double displacement, in double displacement, we're noticing, let me move that up for those people in here. If we're looking at double displacement, otherwise known as double replacement, we have 2 compounds. I know it's a compound because it's got 2 capitals. So I've got 2 compounds forming 2 new compounds. So I've got 2 capitals reacting with 2 capitals to make 2 new things. Law of conservation of mass, I can't destroy matter, I can't create matter, so it has to be those exact same capitals. And I have to rearrange them. Well, if they both had positives, the new ones coming in, we just swapped the positive, right? Or we just swapped the negatives. So it went from AC plus BD. Now I've got AD plus BC. Notice A and B were both written first, right? Which elements are always written first? The positives, right? So I just swapped my positives. That's why it's now A with D and then B with C. Okay, NaCl plus K2S, I swapped my Na, my K. Could I have written KCl plus Na2S? Yeah, think about it this way. In the morning, does it matter whether you put your right shoe on first in the morning or your left shoe? No. All that matters is you put your shoes on after your socks. Doesn't matter which one you put on first. So it doesn't matter which one of these products you write first, as long as you put them on the correct side. Okay, the arrangement doesn't matter. Okay, so those are the displacements. Going on to the next ones. Decomposition. Decomposition just means, or the root word is decompose. Decompose just means to break apart, to break down. When something dies like a tree in the wood, it decomposes, it breaks down. Okay. So you're going to have something that is a tree, it breaks down into smaller pieces, things use the nutrients, and then grows off that. So we have a larger compound, it's going to break into smaller things. Okay, so it's breaking down. There is a dead giveaway for a decomposition reaction. A dead giveaway. You will always have more products than reactants. Dead giveaway. There will always be more products than reactants. So for those people like mathematical formats, I've got a compound A plus B, and it's going to give me A plus B. So AB yields A plus B. Or I can have ABC. I can get A plus BC. ABCD yields AC plus BD. You kind of get the idea? Seems pretty straightforward. Now, if I can take things apart, I can put them back together, right? Think of a Lego house.
I can take the Lego house and I can break it apart, right? Could I also now put it back together?
Yeah, same thing. That's called synthesis, to make. And with that, I'm going to have more reactants than products. So I can take, it's the exact opposite of a decomposition reaction. Okay, so if you look at the two, they are completely reversed in this whole process. Okay. The hint is exactly opposite because the process is exactly opposite. So here's the hint, just count. And that will be your giveaway. And then the combustion. This, believe it or not, is the toughest one for students to get. You are always going to have some type, for those people in the classroom, to magnify it a little bit more. You're always going to have an organic compound, a carbon hydrogen-based compound. That must be present. And you're always going to have oxygen present. It's going to say something like combusts or burns. It may not tell you oxygen is present, but what's required for anything to burn? Could you light a match in space? If you had a lighter in space, could you actually light it? Why not? No oxygen. Okay. It has to have oxygen for something to burn. Okay. So when they say something burns or it combusts, oxygen must be present. So in a combustion reaction, there has to be oxygen as a reactant. Okay. So if they say combustion, it's always going to be there. There's oxygen in the air right now. There's 22% oxygen in our air right now. That's why if I light a lighter, it will light. Okay. But here's the thing. And that actually becomes quite simple because I have to tell you what the organic compound is. You can figure out that, hey, okay, there's going to be O2 there. Here's the thing. A combustion reaction will always make H2O and CO2. Always. Every single time, it will make H2O and CO2. Guess which are the things students forget? That it makes H2O and CO2. And here's the piece. If they forget to include the CO2, did they violate the law of conservation of mass? Carbon went in, did carbon come out? If CO2 is not there, did they violate the law of conservation of mass? Yes, they did. If H2O is not there, did they violate the law of conservation of mass? Yes. So that's kind of a way to remind yourself that, hey, that all has to be there. If O2 is not there, did they violate the law of conservation of mass? Yes. It helps you remember all the pieces that have to be there. So just some examples. Once again, these are straight out of your notes. Okay, these are straight out of your notes. Okay, so with that, what I'm going to do is I've given worksheets here. Those people at home, hopefully you have looked at the worksheets or you printed off the worksheet because that's what we're moving into right now. And moving on to this. Okay, so what we're going to do is we're going to be looking at this. We're going to be comparing. I actually have a hard copy of the reaction types. And on the first one, we're going to go through, and I've started you off. I've given you the full equation. We're going to work on identifying them. Okay. So if we look, and this is the way that I like you to cut, it will help you to begin with, and you can quickly move away from this. If you don't need it, don't do it, but I really advise it. For every capital, assign it a letter. It's going to sound strange. Okay. So with this, like K, I would put A over it. Next one, I is a new element, I'd put B. For P, that's a new element, right? I assign it B. NO3, that's acting as an element, correct? So I would assign that, back up. On PB, I would assign that C. And then for the NO3, I'd assign that D. Let me turn on my lamp, see if it does anything. Not really. Okay. So AB plus CD. Now, if we look through, the reason I assigned that, if we look through that list, do I see anything that kind of follows that format, that mathematical format? Well, it's kind of a hint. Okay. If I go through, do I see anything similar to that? Actually, I kind of changed my, okay, never mind. You're not going to find out from that because I changed something. Whoops. I went straight across. Ignore that I changed something here. So, does anybody know what I changed? Notice what I changed? Okay. I assigned the first two letters to all cations. I went A, B, and then C, D, but down here I went A, B to cations, and then C, D to anions. So you wouldn't get it. But we can do it this way still. K is going to be what charge? No. Plus one, right? We can go. I is going to be what? Minus one. So we've got a compound. We've got two elements there, right? What's this going to be? No. I've got element. Oh, I'm sorry. Yes, thank you for telling me. So probably me magnifying on that didn't help you any. Okay, so if we look at this one, PB is a what? It's got one capital, right? So that makes it an, one capital makes it an thing on the periodic table of the elements. Yes, it's an element. What charge would it have? Well, it's one of the ones that can have multiple, right? Isn't it in that box? So we have to look at the polyatomic or at the negative. So we've got NO3. What's the charge of NO3? Negative 1. I've got two NO3s. So what's my total negative charge? Negative 2. How many lead atoms do I have? 1. Well, what number's down here? What number, if there's nothing written, what's implied? 1, right? So what has to be the charge on that one lead? Well, what minus 2 equals 0? Because remember, it always has to equal 0.
2.
It has to be a 2, doesn't it? Okay, we're reviewing a whole bunch of stuff here. Okay, I'm doing that because that's going to help you in a few minutes. So with this, I know K and I go in, PB and NO3 go in. So when I come out, if PB went in, PB have to come out, right? So I went in, I comes out, and notice that the PB and the I now go together. The K and the NO3 now go together. So I had two compounds go in, two new compounds come out. What does that mean? What reaction type is that? Sorry. What reaction type? Two things have changed places. Two things have displaced each other or replaced each other. What? Double displacement, double replacement. Does that make sense? Two things replaced each other. So if you want to call it DR, fine. done DD since I was in high school, so that's my habit. If you want to put DR, that's fine. I read it the same. So if you ever see a compound plus a compound and they're cations, you're going to be doing that. Okay. So let's balance it. I'll get rid of this stuff. It's already stable. How many Ks go in? 1. How many come out? Great. How many I's go in? How many come out? 2. Great. Problem. If 2 came out, how many have to go in? 2. How do I fix it? If 2 I's come out, how do I make it so the same number go in? Braden, you got an idea?
You make another KI.
You got it. You make it so I got 2 KIs going in. Excellent. Now, as soon as I did that, I just changed something else. What else did I just change?
How many Ks you got in?
I just changed how many Ks came out, didn't I? Now I've got 2 Ks going in, but I've only got 1 coming out. So now I've got to put a 2 in front of the K NO3. So how many NO3s are now coming out? 2. Well, how many went in? 2. And then we have 1 PV, 1 PV, right? And that's what you guys have been practicing is the balancing equations. So on this, we're not going to balance this one. We're going to do reaction type. 1 capital plus 1 capital. If I've got 2 individual Lego bricks, what's the only thing I can do with them? Put them together, right? What reaction type would that be if all I can do is put them together? Synthesis, right? The only thing you can do is put them together. That means synthesis. Does that kind of help? Okay. So you can do the other one. Let's go on this next one. On 4. Now, I've given you names. You've got to change them to symbols first, right? But you can actually come up with part of it first. And this is the way to do it. If I have lead 2 nitrate, is that going to be an element or a compound? Lead 2 nitrate, is that going to be an element or a compound? Lead 2 nitrate. It's a compound, right? Because remember, a Roman numeral means we've got a charge to it. So I'm just going to do this real quick. I'm going to put a C over that. Reacts with, that's our plus, isn't it? Antimony 3 phosphate, isn't it? Can we say that's a compound? Okay. To produce, what does that indicate? How would I show to produce?
Arrow.
That's our arrow. And if something goes in, it must come out, right? So that means we have antimony 3 nitrate. That has to be a compound. And's probably going to be our what? A plus sign. And then lead 2 phosphate. So I've been able to identify that just based off the names, right? Can you tell me what reaction type that is? I have a compound plus a compound, and I make 2 different compounds. Double displacement. Does that make sense? Does that follow the format that we saw on this? Yeah. So you didn't even have to do anything on finding names and formulas. Some of them are actually even easier. What does the word breaks down mean? What's another way to say breaks down? A tree falls down in the forest. What's it ultimately do?
It decomposes.
It decomposes, right? So what reaction type would that be? Decomposition. Does that make sense? Yeah, just based on the word. Here's where you're actually going to be putting it to work. And this is where the heart of the problems come to be. Okay, the first part was just getting some recognition. Because here is where you actually have to predict what your products are going to be. And knowing the reaction types are the key pieces. So this is what I wanted you guys to be getting. But it follows the same process. MgOH2, is that an element or a compound? Compound. Na3PO4, is that an element or a compound? Compound. I have a compound plus a compound. What reaction type is that probably going to be? Double displacement. Does that make sense? Two compounds reacting to form two new compounds. So AC plus BD, now we have AD plus BC. We're swapping the positives, right? So I'm going to go through and I'm going to make sure I swap my positives. Look at number 8. Al, is that an element or a compound? Element. O2, is that an element or a compound? So I have an element plus an element. Is that single displacement? No, because single displacement, we have an element and a compound. I don't have a compound. Double displacement says we have two compounds. I don't have two compounds. Decomposition says we have a compound. I don't have a compound. Synthesis, taking elements, I got that, and or compounds, and making them into a bigger compound. Could it be that? Yeah, it definitely could. So it says AB plus C equals ABC. So what if I didn't have C? Would that work? Yeah. If we look at the examples, H2 plus O2 use H2O, doesn't it? That follows that pattern. So yeah, it definitely could be C. And we can look at the last one. Does the last one even apply? Nope. So that would mean that that one has to be. And what that means is now we put it together. ALO. What's the charge of aluminum? Plus 3. What's the charge of O? Is this a stable compound? How do I make this stable? How would I make that stable? What was the trick we showed you early on? Cross them down. Excellent. Now, currently I'm violating the law of conservation of mass. So what do I have to do? Yes, Henry, that's right. We have to balance the equation. Excellent. So with that, I have one AL going in. So I have to have 2 coming out. So if 2 come out, that means I have to have 2 going in. So we're going to put a 2 there. Put it faint right now because we may have to change it. Who knows? Okay. So now if we look, I have 2 oxygens going in. I have 3 coming out. Well, I cannot put anything in front of this to make it a 3. Okay. I can't put anything in front of this to make it a 2, but I can find the lowest common multiple.
The first number that 2 and 3 both go into is what? 6. So if I put a 2 in front of this, because I cannot touch my subscripts, I'm going to have 6 auctions going in. And if I put a 3 in front of this, 3 times 2, now I've got 6 auctions coming out. You're right, Henry. That's why I didn't put that very dark. Because now 2 times 2 is 4. So I actually need a 4 in front of that. Because now I've got 4 aluminums here to match the 4 aluminums there. So now I've balanced that. Yes, Gertrude, I'll go back on this one. Okay, so if we got this, we say it's double displacement. Magnesium. Yes, Henry, I could have done the sodium first. Okay, magnesium goes first. That's good. That's what I wanted to do. Okay, magnesium, what charge? +2. Excellent. And basically positive, I'm going to go with the other negative, which is PO4. Remember, negatives are always written last. Our periodic table, we look at the bottom. It says it's a +3 or -3. We cross them down. Well, what's the very next thing we do after the cross down? Jordan? Sorry. Yes. Come get a pass. And apparently you're the last person until I can get more passes. So everybody else just gets to cross their legs and do the potty dance. Sign out and then back in.
What did you say?
Sign out, then back in.
Oh, I didn't hear what you said before that.
That's okay. You can watch the video later and find out. So
Absolutely do that.
I know you will. You'll take notes and you'll send them back to me. Okay. So with that, okay, remember, cross them down, then always find out, can it reduce down? If so, you have to. Okay. So I just took care of that piece, and I took care of that piece. Now I've got to take care of my sodium and my hydroxide. Which one goes first? Which one always gets written first? The positive. Actually, so the sodium. And then the hydroxide. Do I carry this 2 over? Do I carry this 2 over? No. That 2 was there only to make this compound stable. Just like this 3 was there only to make that compound stable. That's why we always have to put our charges up. That's why it's so important you actually be able to figure out what those were. And now I balance those. Who can give me a shot on balancing that? Okay, Gertrude, what do you got? Okay, put a 3 in front of the mg. So we got 3mg, 3mg. Okay, that's going to give me 6 OHs. So 6 OHs go in. So 1 go out. So, okay, yep. We'll put 6 going out. That means we have 6 NaOHs go out. Yes, Henry. That means we have to have 6 going in. So we'll put a 2 there. So now we've got 2 PO4s, 2 PO4s, 3 MGs, 3 MGs. Okay, excellent. So notice we predicted products, then we balanced the equation. The only difference down here is I'm taking you all the way back to names. So you have to go through and you have to create these. And then you can predict your products. Knowing the reaction type helps. So go ahead and work on those. I will post a key for this. And then you have a worksheet where I'm going to have you enter answers for a learning check. And you'll be doing that later on this week. But I'll post a key for this so you can double check your work. So those people at home, I'll post a key very quickly.